we want to see whether we can use our expertise to solve this energy crisis problem. We will try to see whether we can use a plant material to convert them to biofuel.
For the last 15 years, we've been involved in identifying and characterizing genes that are essential or important to the differentiation and function of vascular tissues in plants.
So our hope is we could make plants that would grow bigger, more biomass, or be less susceptible to stress. And so the more we can accomplish that, the better these plants will be to use for things like bioethanol or biodiesel.
We want to understand genes and how they function in poplar. What genes are important for adaptation in natural environments, what genes are important for sustainable production of biomass.
My main focus is in the increase of cellulose in plants, but because cellulose is such a big raw material for the production of bioethanol.
Most recently, we have been working with creating poplar transgenics that are altered in their level of expression for genes that we think are important to wood formation. And in fact, this room is dedicated to the production of transgenic poplar plants, and all of the plants that are around me on the shelves here are poplar plants that have been altered with regard to expression of genes that are important either to shoot architecture of poplar or perhaps the production of wood.
Using tissue culture and also transformation techniques to try to improve feedstock quality of switchgrass. In another word, means we're making new switchgrass cultivar that are easier to be converted to biofuel.
We all know that soybean is an important source for food and biofuels. So my work actually will be providing the fundamental and the mechanisms for people to engineer the soybeans into producing more oil or protein or carbohydrates for different purposes.
Plants that are more stress resistant will allow farmers to plant fewer seeds, take care of fewer plants, and have the same harvest or even bigger harvest.
So by manipulating individual genes, we can see how those interact with nitrogen signaling and how that affects crown architecture, crown form of the tree.
And all of this can lead to alternatives for fuel production that depends upon the cellulose that's found in the cell walls of wood.
And we also want to improve switchgrass biomass yield. In that case, you use less land that can produce more biomass, so we can produce more biofuel.